Hello everyone, in this video we're going to explore the topic 2.4 exponential function manipulation of the AP Precalculus. Alright, so first we need to revisit the concept we learned in Algebra 1. Alright, so if I have a to the m times a to the n, so it's going to be a to the m, okay? So which means you need to add the exponent. So look at this example right here. I have 2 to the third times 2 to the second. Alright, so it's going to be equal to, I need to rewrite the same base. Now I need to add the exponent up. So 3 plus 2 is going to be 5. So I have 2 to the fifth, and it turns out to be 32. Alright, now second formula we're going to talk about in this topic is going to be this guy right here. If I have a to the m all together to the n, so it turns out to be a to the m times n, right? So for example, if I have 2 to the third all together square, so it turns out to be 2 to the 3 times 2. It's going to be 2 to the 6, and it's going to be 64. Alright? And the last one, this formula right here. If I have a to the negative n, so if you see the negative power, alright, you need to make it positive. So how do I make it positive? I just flip this one, alright? So it turns out to be 1 over a to the n, alright? So for example, if I have 2 to the, it turns out to be 1 over 2 to the third. It's going to be 1 over 8. Now, what if I have 1 over a power of negative n? So I need to make this one positive. So I just flip this one. So it turns out to be a to the n over 1. So which means a to the n. Alright, so here's the example. 1 over 2 to the negative 3. It turns out to be 2 to the third over 1, which is 8. Okay. Now, next one. If you have a over b all together power of negative n, right? Now, you need to make this one positive. You just flip the fraction right here. A over b turns out to be b over a. And then the exponent turns out to be positive. Now, look at this one. 2 over 3 power of negative 2. I need to make the positive power. So I need to flip this guy right here. So it turns out to be 3 over 2 power of 2. And it turns out to be 3 power of 2 over 2 power of 2. And it's going to be 9 over 4. Alright, so we have more formulas right here, and you need to revisit the concept you learned from Algebra 1. Okay, so next one, we're going to talk about the exponential function. So exponential function is given by f of s equal to a times b power of s, like that. Okay, so keep in mind only b power of s, not a. Okay, so in order to get rid of any mistake, please put parentheses like this so that you're not going to get any mistake, right? Alright, so a right here is the initial value of the y-intercept. Okay, we have the transformation. Okay, this is topic 1.12, so we need to review the concept right here. So this is s minus, this is horizontal translation. Okay, then this is plus k, this is vertical translation. This is b right here, this is horizontal dilation, and this is vertical dilation. Now keep in mind, anything related to s value, do opposite. Okay, anything related to y value, do exactly what's given. Okay, right? So for example, if I have the function f of s equal to 5 raised to the s plus 3. Now keep in mind we have the vertex form. It's going to be f of s minus h plus k, right? So we have 5 to the s plus 3. Alright, so you see that this is s plus 3, this is s minus h, and you have the negative side over here. So I put s plus 3 over here, right? Now, how do I use this formula? Right? So I need to rewrite s over here. I need the negative side right here, so I put the negative side right here. So in order to get plus 3, doesn't mean I have to subtract 3 like this. So in this situation, h equal to negative 3, right? So if h equal negative 3, which is less than 0, the function moves to the left 3 units, right? Or you can use a trick. Anything related to x value, think opposite. So this is the plus side right here, turns out to be minus side. Minus side, which means you're going to move to the left, right? And it's horizontal translation. So the function y equal to 5 to the x shifted to the left 3 units to create the function f of x. Now, take a look at this one right here. So I can rewrite the function f of x as the following. 5 raised to the power of s times 5 raised to the power of 3, right? Because I use the formula right here, right? So I can rewrite this one as 125 because 5 power of 3 equal to 125 times 5 power of s. Makes sense, right? Okay, so this turns out to be vertical dilation because this is the output, right? So 125 multiplied by the output, which means the value of a right here. And this is vertical dilation by a factor of 125. So you see that from the original problem right here, we have the horizontal translation, right? Now, after manipulating this function, and it turns out to be vertical dilation. You see that? Now, let's take a look at the next example. F of s equal to 2 power of s minus 4. Alright, so we're going to use the formula right here. Alright, so we need to rewrite this one as 2 to the s over 2 to the 4, right? And then it turns out to be 2 to the s over 16, right? So you can rewrite it as 1 over 16 times 2 to the s, right? Now, originally, this is the horizontal translation of the function y equal to the s to the right 4 unit to get f of x. Now, after manipulating, we get the final function right here, right? This guy right here still f of x, right? So the second way to understand this one is the function y equal to 2 to the s after a vertical dilation by a factor 116 to get f of x. So keep that in mind, this guy and this guy should be the same, right? It's just different ways of transformation, but they're both the same. Now let's take a look at the next example. So for example, if we have the function f of s equal to 16 raised to the s over 3. Alright, so I need to rewrite this one as 16 raised to the 1/3 of s like this. Alright, so because 1/3 right here is the number in front of s right here. So think about this one right here. Right? Anything related to s, think opposite. So which means the function y equal to 16 to the s is horizontal dilated by a factor of 3 to get f of x. Now let's take a look at the next example. For example, if I have the function g of x equal to 3 times 5 raised to the s plus 4. Right? So how do I get the function g of s? Right? So I need to split this one. Right? So the function g of s comes from the function f of s equal to 3 times 5 to the s, and shift it to the left 4 units to get g of s. Right? Now we need to manipulate this function. So I just rewrite this one as 3 times 5 to the s times 5 to the 4. Right? What I got right here, the formula right here. Alright, so I just simplify this one. It's going to be 3 times 5 to the s times 625. Then I'm going to simplify 3 times 625, which is 1875 times 5 to the s. So this is actually the function h of s equal to 5 to the s, right, is vertically dilated by a factor of 1875 to get the function g of s. Now let's move on to the next example. So let's compare the function f of s equal to 256 power of s, and the function g of s is going to be equal to 16 raised to the 2s. Alright, so we can start from the left, right? So 256, we just write it's going to be equal to 16 times 16 all together raised to the s, right? So 16 times 16, which means 16 square all together raised to the s, right? And then we're going to apply the formula right here. Alright, so it's going to be 16 raised to the 2 times s, and this is exactly right here. So f of s and g of s, they're both the same. Now let's move on to the next example. For example, if I have the function f of s equal to 5 times 36 raised to the s over 2, and the function g of s equal to 5 times 6 raised to the s. Now we need to compare to see if this guy and this guy are the same, right? So we start from here. So we need to manipulate this one. So it turns out to be 5 times 36 right here. I just write 36, it could be 6 square, right? And then all together raised to the s over 2, right? And then I'm going to use this formula again right here. And then I just multiply the exponent, right? So it's going to be 5 times 6 all together raised to the 2 times s over 2, right? So I'm going to cancel out this guy and this guy. So it turns out to be 5 times 6 raised to the s, and this is exactly the same thing right here. Alright. Now let's move on to the last example. For example, if I have a function f of s equal to 4 times 125 raised to the s over 3, and I need to compare this one with g of s equal to 4 times 5 raised to the s. Alright, so I'm going to do another way. So I start from here. So I need to manipulate this one. So it turns out to be 4 times, right? Now it turns out to be 125 raised to the 1/3 s, right? S over 3, I just rewrite like this, right? This example I'm going to do slightly different from reverse example to make sure you learn different ways. Alright, so it turns out to be 4 times 125. Now look at this one, 1 over 3 times s, right? So I'm going to use this formula right here. Okay, so I convert this one back to this one. So I have 125 raised to the 1/3 all together to the s, right? Now next one, I have 4 times, right, 125 raised to the power of 1/3. So I use the formula right here. Alright, so it turns out to be cube root of 125. Alright, all together raised to the s, right? So it turns out to be 4 times. Now cube root of 125, which means 5. So I have 5 raised to the s, and it's exactly the same thing right here. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.